My name is Paul Sohi. I'm an industrial designer for Autodesk. I like to build things, take on design challenges, and collaborate with designers, engineers, and fabricators from all over the world to build better things. They have some pretty great stories, and these are some of them. Welcome to Intersect, presented by Redshift. D-Rev, as I understand it, you guys focus on products for newborns, right? And developing medical assistance for them. Your first product was to treat jaundice, right? Mm-hmm. Can you tell me what you guys are making?
We're still focusing on newborns. In the past, we've also focused on amputees. But we, in general, are a nonprofit that makes medical devices specifically for low-resource markets. So our primary markets are India and East Africa. We've also done some stuff in Latin America. But the current product we're working on is for premature babies who have respiratory distress. So we're designing a device called CPAP, which is continuous positive airway pressure, basically just blows into the baby's lungs. If you're born really early, basically your lungs are really sticky. So when you breathe out and like the little air sacs close, they actually get stuck and they can't open back up. So we're just holding the little air sacs open.
So it's like a 21st century iron lung or a...
So CPAP has traditionally been used for old snoring men. Their throats sort of collapse, and so they snore and you hear the vibration of their throat parts hitting each other. Babies don't snore, but lower down in their airways, that's where it collapses. And so it's essentially just a fan that's blowing a specific amount of pressure. For babies, it needs to be heated and humidified and mixed with oxygen because they're delicate.
I feel like baby snoring would be super adorable though, right?
Yeah.
It's like little, I don't know what it would sound. Yeah, basically, right? Well, yeah, I guess if you've got sticky lungs, it would be...
Yeah.
You guys are testing soon, right? You mentioned that you're going out to test the new stuff. Can you tell, what's that look like?
Yeah. Next week, I, along with my colleague Casey, will be heading first to India, where we'll go to about 5 hospitals, and we'll take a fully functional prototype of our CPAP with us, and we'll run doctors and nurses through a simulation. So we will not be using the device on babies. That will happen in the beginning of next year. But in this study, we'll be running them through a simulation, and this is a human factor study. So we'll be looking at where do they have problems, where do they get confused, how can we make it simpler, how can we make it integrate into their hospitals better. So some of it will be simple things like the shape and the size and the way that it mounts on a pole or sits on a table, and then some of it will be around the setup of the device. So we have, since people will be speaking an assortment of languages, all of our instructions and manuals are pictorial and are actually, they live in the device, so it just comes up on the screen, because things tend to disappear in hospitals. If you have a little booklet, it won't be there. So we'll run people through setup, and then during the actual use of the device, we'll see our users understanding what's going on. In most parts of the world, nurses who work with babies in NICUs, neonatal intensive care units, they haven't gotten any neonatal training. They've just gone to nursing school and then here's babies. And babies are slightly different than just small humans.
Went to nursing school and then here's babies is quite a statement.
Yeah. It's quite a situation. Yeah, and so nurses will also, there's just a lot of turnovers. You might be in the NICU for a couple months, maybe a year, and then you'll get a whole new batch of nurses. And so the idea that someone should understand how the pressure and flow and temperature in a CPAP device, how they're all related to each other and be able to troubleshoot when there's problems is sort of unreasonable to expect of people.
Right.
And so one of the objectives of our device is to just be really easy to use. There's actually really high quality CPAP devices in hospitals we go to in India, and they're either sitting in the corner unused or they are used, but because there's not a single nurse for a single baby to monitor what's going on all the time, the baby might be connected to CPAP but not really being delivered effective therapy.
Sometimes it feels like a loaded question to ask, or it's a little kind of weird, but like, what does success look like to you? If you were to look back on it at a certain point in time and be like, yeah, what is that moment for you?
Success looks like our devices being in hospitals that currently weren't delivering high-quality CPAP, hospitals that are able to now keep babies that have respiratory distress rather than just referring them up to a higher-level hospital where likely they either won't make it all the way to the higher-level hospital or the higher-level hospital will be too full and we'll have to turn them away. So really just increasing the number of facilities that are able to deliver CPAP. With CPAP, the mortality rate of respiratory distress syndrome drops from, if you have no treatment, mortality rate's about 99%. With oxygen, mortality rate's about 75%. With CPAP, mortality rate drops to about 25%.
So D-Rev's been around for 12 years. You guys have solved a number of problems already, and you're here at the San Francisco Technology Center. Why is now the right time to solve the problems you're currently addressing?
I think a few things make now sort of ripe for innovation, specifically in respiratory distress for neonates. One is that oxygen access is expanding, and you can do a lot more with oxygen plus CPAP than just one or the other. That just makes CPAP more effective.
Right.
Technologically, our device uses sensor technologies that will then take the burden off of nurses so that they can be actually helping all 20 babies in their NICU instead of just the one that's on CPAP. One of our flow sensors came onto the market probably 4 months ago. So what we're doing at the price point we're targeting just wasn't physically possible with the state of particularly flow sensors for really tiny flows that babies breathe in. And so I think it's really those two things, on the technology side, sensors. Also, blower technology, just like how strong you can get a fan to be while it's still really small and really quiet. That has come a long way in the last 10 years. So instead of having to have a giant compressor with manual flow meters, now you can have a little fan and a flow sensor and do the same thing.
I think it's fair to say, on some level, you essentially had to wait for tech to catch up to your ambition, right?
Yeah, we started this project a couple years ago, and the flow sensors were just this bottleneck. And we had found a way to make it work, but it was kind of expensive and not as good as it could be. And then within the last 6 months, it all of a sudden was time to do this.
I mentioned earlier I'm an industrial designer, which basically means like the bad version of an engineer, essentially. So when I was at university, like 3D printing was an available technology, but incredibly expensive, and we only had one of them. And it was this old Z-Core machine with the gypsum plaster. And I studied architecture at university and did what every architect who doesn't want to be an architect does. I switched to industrial design. And what I found really interesting for me at the time was there was this tech that like kind of opened my eyes to the possibilities of things that I could make. And I found that it radically changed my design style, and I was trying to do more ambitious and more complex things. So I was wondering for you and for D-Rev, and then also in bioengineering, how have these like technological advances changed your relationship to like the process of arriving at a solution, but also the actual solutions themselves?
The design process has been completely changed for me over the last few years with 3D printing. And I built a CPAP yesterday, and today I'm building one with a very different design because we were able to print the parts that we needed. That just wasn't possible before when I was machining every component or making plastic parts out of styrofoam for models.
I don't miss those days.
No, it just took so much longer. And now I can do design work for the first half of the day, make changes the second half of the day, have the parts make themselves overnight, and then start it again in the morning.
I love that description. Have the parts make themselves.
They do. Yeah, they're making themselves right now.
That's awesome.
So that when we finish, I can go and use them. It's like multitasking to the nth degree.
It's funny, essentially what we're saying is the same thing that like the generation before us said, the generation before them said, like all the way back to like pencil and paper. It's funny that we've never learned. So to change gears for a second, pineapple on pizza, yes or no?
No.
This interview is over.